linear equations is going to be a little interesting because some of us learned different material last year than others did. In 7th grade, we had a lot of flexibility on how far into linear equations we're able to go. So for some of this, S1 and S2 are going to feel almost entirely like review. But for others of us, it's going to feel like totally new material that you're seeing for the first time. So make sure that you're communicating with me on if you need more practice or more examples, or if you feel like maybe it's a little bit too easy for you and you want some more difficult material. The videos are going to teach from the perspective of someone who's seen a little bit, but not very much. So I'd say these videos will target at that level 2 and level 3 range. So they will not be for everybody. Now, before we start solving linear equations, there's two main key words in linear equations that we need to talk about. When you see the word linear, hopefully you know by this point that we're talking about a line. So something that is, when you would put it on a graph, would create some type of vertical line with a consistent rate, a consistent slope. We've worked really heavily on y equals mx plus b. That's obviously the most simplistic linear equation that we know. So many times we're going to be solving the same types of things. But also important to identify that when we're solving a linear equation, right now there can only be one variable. So if you see an equation that has more than one variable in it, we can only graph it right now. We can't solve it. And when we're talking about an equation has the root word of equal, which means there must be an equal sign. So if you're working with something that does not have an equal sign in it, you cannot solve it. Now, when we talk about linear equations, most of the time we talk about something like this. We have a variable in here that we are trying to solve for and figure out what value of x makes this equation true. So if you remember from last year, the first and most important thing I like to do is draw a line down the equal sign. That makes me think about this like the middle of a scale. And we're always trying to keep the scale balanced. So in this equation, I find the variable x. I want to find the number that's farthest away from x, but still on its same side. So the 2 and the x are very close together, but this 3 right here is a little bit separated. So I want to do the opposite of positive 3, which is negative 3, to both sides of the equation. And I do it to both sides of the equation to try to make sure the scale is always balanced. Then I simply simplify each side. Negative 3 and positive 3, well, that's 0. So the only thing left on the left side of the equation is positive 2x. The only thing left on the right side of the equation is positive 2, because 5 minus 3 is positive 2. Now, if you see a 2 and an x next to each other, and there's no operation between them, that means they are being multiplied. So I am going to divide both sides by positive 2, because 2 divided by 2 gives me 1x, or just x, which is what we want. 2 divided by 2 is 1, which is also what we want. You can write the equation as 1x equals 1 or just x equals 1. Either way is totally fine with me. But I always want you to plug it back into the original equation to see if it worked. So I'm going to do 2 times 1, because our x is 1, plus 3 is equal to 5. And we want to know, is that a true statement? Well, 2 times 1 is 2. 2 plus 3 is 5. So I put a check mark that says we are correct. Let's move on to the second example. Now, as we work through this problem, if you are having trouble with these types of problems, we call these parentheses distributive property type problems. There is a video specifically designed for them. So talk to Mr. Schmidt and I can get you onto the right video. But for right now, when you see a parentheses, the first thing you have to do in this problem is get rid of the parentheses. And the way you get rid of parentheses is by using the distributive property. Now, the distributive property means 2 times the value x minus 8. That means this value twice. And on the side, I'm going to write it the long way. You do x minus 8 plus x minus 8. That means 2 times this, which would be 2 x's, and negative 8 plus negative 8 is negative 16. Now, the shortcut is, it's called the distributive property, because you are going to distribute the 2 into both terms underneath the parentheses. So this becomes 2 times x and 2 times negative 8, which gives us the same thing we did over here, 2x minus 16 equals positive 17. If you are a little confused by this process, there is a video dedicated to just that. But the distributive property is not nearly as hard when you get used to it than it is right away. Now the problem is exactly like what we just did. I'm going to add 16 to both sides of this equation to keep it balanced. I'm going to draw my line and simplify. Negative 16 and positive 16 are equal to 0. So the left side has just 2x. The right side has positive 33. Now I am going to divide both sides by 2. This gives me 1x. And this gives me a couple different things. 33 halves, or I think most of us would probably like to write this as 16 and a half, because 32 divided by 2 is 16. There'd be an extra 1/2 left over. So you can write your answer either way. And then we're going to plug it back into the equation to check. 2 times 16 and a half minus 8, is that equal to 17? Well, 16 and a half minus 8, well, 16 minus 8 is 8. So the extra half is going to make this 2 times 8 and a half is equal to 17. And that is true, because 2 times 8 is 16. 2 times a half is an extra 1. So this is true, which means we are correct. So decimal answers, fraction answers are just fine. Not a problem at all. I know we are middle schoolers, so we get a little panicked when we see those, but that is okay. Now, I've covered this one up, not super great, but what I'm going to try to do here, if I can keep it covered. There we go. So we have x divided by 2 plus 3 is equal to 4, which is not the same thing as here on the right, which is x plus 3 divided by 2 equals 4. These problems are very close to the same, but they are not equal. So what we're going to do is we're going to solve each problem separately to show you what the difference is. The problem on the left is going to be solved just like the problems we just did. We draw our line down the equal sign, and I'm going to subtract 3. Whoops, sorry about that. I'm going to subtract 3 from both sides. When I subtract 3, that's equal to 0. So I get x divided by 2 is equal to positive 1. Now, the last few times we would multiply or divide at the end, we are going to do the same thing here. X is being divided by 2. The opposite of dividing by 2 is multiplying by 2. Dividing by 2, multiplying by 2 are opposites, so we just have x or 1x left. On this side, we have just positive 2 left, so our answer is x equals positive 2. We once again can plug it into the equation to check. I'm going to do 2 divided by 2, because it's x divided by 2, plus 3, and that has to be equal to 4 for this equation to work. 2 divided by 2 is 1. 1 plus 3 is equal to 4, right on the nose, so it worked. But if we look at the problem on the right, the difference is it's x plus 3 and everything is being divided by 2, which means we are going to be doing the opposite order that we just did before. Instead of subtracting first, we have to multiply everything by 2 right away to get rid of this fraction, because the fraction is dividing every term by 2. So I'm going to get instead x plus 3 equals 8. Now I subtract 3 from both sides of the equation, and I get x equals 5. Once again, let's check our answer. 5 plus 3 all over 2 is equal to 4. This now becomes 8 divided by 2, and that is true, so our check works. So be very cautious about that fraction. If the fraction is just dividing x, you can do it at the end. But in this example, I always ask the question, which number is furthest away from x? In this example, the 3 and the x are pretty close. The 2 is actually farthest away. In this problem, the 2 and the x are pretty close, and the 3 is furthest away. So that determines which number we have to get rid of first.